In section 6.4, we are solving polynomial equations, and the polynomial equations we will be solving will be degree 3, and eventually in the second half of the lesson we'll talk about solving degree 4. These cubic polynomial equations are considered to be a special case. We're going to be solving equations, degree 3, that represent either the sum or the difference of two perfect cube numbers. And what I mean by perfect cube numbers, two different numbers, terms that have perfect cube roots. So what I have written in the blue, which represents how the factoring of the sum of two cubes is done, and the red represents how the factoring of the difference of two cubes is performed, that's going to be a big part of what you're going to do in the first half of the lesson. So let me walk through some examples, and we're just going to follow this procedure for either the sum of two cubes or the difference of two cubes. So let's look at a sum of two cubes problem. So I'm going to follow the blue guideline. So this says in the binomial, the linear binomial represents the cube roots of each of these terms. So A really stands for, in this case, what is the cube root of 8x to the third? And that would be 2x. Notice that for the sum of two cubes, I'm going to put plus in this linear binomial. And B will represent the cube root of the second number, which in this case, the cube root of 125 is 5. Okay? The trinomial factor is really going to be built based on these two terms. The 2x in this problem will be the A, and the 5 will represent the B. So inside this parentheses for the trinomial, I'm going to do A squared, and you really need to think about this. A is 2x, and if I square that, I get 4x squared. Okay? Notice the next sign is subtraction, and I'm going to subtract the product of A and B. 2x times 5 is 10x. Next sign is plus, and then this says to take the B term, which is 5, and square it, and I get 25. Okay, that's an example of how we would factor the sum of two cubes. Now let's look at the difference between two cubes, which I have in red. Well, it's very similar. I start my binomial, the linear binomial, will be the cube root of each of these terms. The cube root of x to the third is x. I'm going to use this sign. And the cube root of 27 is 3. Okay, the trinomial, quadratic trinomial, will be built off of these. This is the A term. This is the B term. So I do a squared, which in this case will be x squared. Notice the next sign. It's plus, and it's always addition. When you're factoring the difference between two cubes, you really have to think of the B term as just being 3. We are subtracting 3. Don't want to think of it as negative 3. It's literally 3. So if I multiply 3 times x, I get 3x. And then finally I'm going to add the B term squared. 3 squared is 9. So that represents the factoring of the difference here of these two cubes. Alright, so let's take a look at how we would apply this factoring process in solving equations involving either the sum or the difference of two perfect cubes. Alright, well I have the difference of two perfect cubes here, so I'm going to start by factoring the cube root of the first term minus the cube root of the second, and then my trinomial, quadratic trinomial, will be the first of these terms squared plus these two terms multiplied together, 3x times 1, plus the b, the second term, squared, which is also 1. Well, factoring makes it easier to solve. So the way I need to approach this now is let each one of my factors equal 0, and I solve each one of these as a separate equation. And remember, it's cubic. The degree of this polynomial is cubic, so I should end up with a total of 3 solutions. So solving this linear equation, obviously that's pretty easy. I get 1/3 as one of my solutions. Now this is a quadratic equation. It can't be factored because there are no factors of 9x squared, factors of 9x squared and 1, 9x squared. There are no factors of 9x squared that add up to 3x. So I'm going to use the quadratic formula. So using the quadratic formula here, I get the opposite of b plus minus the square root of b squared minus 4 times a, which is 9, times 1, that would be minus 36, all over 2 times a, which is 18. So just simplifying the radical underneath the radical, that's negative 27. Okay, and hopefully you remember that the square root of negative 27, using the number I, and what we know about simplifying radicals, that would be 3i square root of 3 all over 18. Now we don't want to stop here because we have an opportunity to reduce or simplify. We can divide the number 3 into all of these numbers that are not under the radical. So 3 into negative 3, 3 into positive 3 is 1i square root of 3, and then 3 into 18 is 6. So because that says plus minus, that really represents 2 solutions to go along with the other solution that we found at the beginning to make a total of 3 solutions. Now somebody asked me earlier, could you show this using completing the square? So here is solving this quadratic equation with the formula, quadratic formula. Now let's take a look at it if we use the completing the square method. And I'm not particular. You can use whichever one you feel most comfortable with. Alright, so for completing the square, 2 things have to happen. First of all, this constant needs to be moved to the right side. Secondly, any number that's in front of x squared besides 1, I need to divide by that number. So I'm going to be dividing by 9. And 3 divided by 9 is 1/3 x, and that equals negative 1 over 9. Okay, so I'm going to set up the quantity squared, and in the parentheses, x plus, if you divide 1/3 by 2, remember we always divide by 2, that's the same thing as multiplying 1/3 by 1/2. So dividing this linear coefficient by 2 would give me 1/6. So the number that I use to add to both sides that creates a perfect square trinomial is 1/6 squared, which is 1 over 36. Okay, now let's change negative 1/9 into 36, which would be negative 4 over 36. So negative 4 plus 1 is negative 3 over 36. Now you do the square root of both sides. And don't forget plus minus. So on the left side I get x plus 1/6. On the right side I get plus minus. The square root of negative 3 is I square root of 3. And the square root of 36 is 6. So to finish this off, I'm going to get negative 1/6 plus minus I square root of 3 over 6. Or, if I put it all over common denominator 6, erase this so you don't get confused, you can just put these numerators together, negative 1 plus minus I square root of 3 all over 6, which is what we got using the quadratic formula. Alright, let's try this one. Factor it as the sum of 2 cubes, x plus 5, the cube roots. Now remember, the process for factoring, square the first term, minus, don't forget, it's subtracting a times b multiplied together, which would be 5x, and then you square the last term, the b term. Solving this linear binomial is pretty simple. It's x is -5. Unfortunately, over here for the quadratic, I'm going to have to either use the quadratic formula or I'm going to do completing the square. And I'm going to go ahead and show this one using the formula. The opposite of b plus minus the square root of b squared minus 4 times 1 times 25, that's minus 100, all over 2 times 1. Okay, 5 plus minus the square root of -75, all over 2. Now, just a little review on how to simplify these radicals. If you don't know, we could break this up into these radical factors. Okay, square root of -1 is I, square root of 25 is 5, and this radical can't be simplified. So we would say 5i square root of 3 all over 2. And nothing goes into 2 and 5, obviously, besides 1, so we can't reduce this anymore. So because that says plus and minus, that represents 2 solutions, and x equals -5 is the third one. All right, let's try one more. Let's find the cube roots. And then remember how to build the trinomial factor, quadratic trinomial factor. Square this first term, subtract 2x times 5, and then square that last term. Set each of your factors to 0 and solve. Setting this quadratic trinomial to 0 and solving. Since it doesn't factor, I'm going to use the quadratic formula, the opposite of b, plus minus square root of b squared, minus 4 times 4, or you could do 4 times 100, which is 400, all over 2 times a, which is 8. Okay. We have the square root of -300 all over 8. And if you wanted to simplify the square root of -300, you could think of the square root of -1 times the square root of 100 times the square root of 3. 10i square root of 3 all over 8. And we can simplify this a little bit more by dividing 2 into both 10 and 8. So 5 plus minus 5i root 3 all over 4. Okay, those are 2 solutions to go along with -5/2 as the third one. All right. The other type of problem that you're going to be doing, and I've shown you some examples from your homework, you're going to be solving Hortic trinomials. Well, first of all, let's see how we factor those so that the factoring then can help make it quite a bit easier to do the solution when we do have to solve. Well, I want to use this as an example because this is very familiar to you. Let's go back to the days when we were solving or factoring quadratics, quadratic trinomials in this form, and we were solving factoring by multiplying 2 linear binomials together, and we noticed that -27 does have 2 factors that add up to -6. That would be -9 and +3. So this factoring was pretty simple. these two linear binomials multiplied together would equal this. Well, the only difference really, this is very similar in factoring this Hortic version. The only thing that needs to happen to this answer to make it equal to this is that each of these terms, instead of being linear, they need to be quadratic. So literally, the way you factor these is the same. It's just that now, to make x to the fourth, we're going to have to multiply x squared times x squared. Now, something that we need to keep in mind, we're supposed to factor, and we should be factoring fully. I noticed that with this first binomial, I have the difference between two perfect squares. So I can keep factoring here, because x squared minus 9 factors as x plus 3 times x minus 3. Now this binomial does not factor anymore, so this represents my final answer. Just be careful that when you're asked to factor, that you factor as much as you can. Don't leave any possibility of more factoring that can be done. Okay, so let's try another one of those. Here's another Hortic trinomial. So just think about the way you used to factor the quadratic trinomials. Are there factors of negative 45 that add up to negative 4? And that would be negative 9, positive 5. And again, instead of two linear binomials, we're going to have two quadratic binomials. All right, so set each of your factors equal to 0. Keep in mind that the degree of 4 tells me that I should have this many solutions. So 2 of my solutions will come from solving this quadratic equation. I'm going to solve by square roots. Okay, square root of both sides. And don't forget plus minus. Remember, I should be getting 2 solutions. So 2 of my solutions will be positive 3 and negative 3. Now I'm going to do the same thing over here. Solve by square root, so I subtract 5. Square root of both sides. Plus minus. X is going to be plus minus I times the square root of 5. Alright, I was looking for 4 solutions and I found them. 2 of them are here. 2 of them are here. Okay, and that is the homework, or that's the lesson that was taught in class today for section 6.4 to hopefully prepare you for the assignment. I just wanted to throw this one out at you. This is actually one of your homework problems, but I didn't want you to be confused. You need to, before you do anything else, you need to set this up so that it can be factored. And that means standard form equal to 0. And when you're factoring, you need to make sure that this lead coefficient, the number in this case in front of x to the 4th, is positive. Okay, so I'm going to write this in a form. It's equivalent, but it's in a form where we can do some factoring, and then we can do the solving. All right, so I'm just going to move x to the 4th to the left with addition, and then I'm going to move minus 12x to the 2nd to the left with addition. 27 is already over here as positive 27. Now I'm ready to proceed with what we've done before, come up with the factors of 27 that add up to 12, and come up with your 4 solutions. So I'll let you take it from there. I just wanted you to be aware of how this needs to be set up so that you can solve it. All right, and that's the assignment. And let me know if you have any questions, and we'll check these out tomorrow.